Ladies and gentlemen, good evening. AI, machine learning, classification. It has never been easier than it is now because Google and also all the other cloud providers there. There are a lot of other systems that are helping us so much that it's so easy. You do not have to switch your brain on. You can just turn off your brain almost, and then you can. Of course, that's a lie, but you know what I mean. It's much easier than it was in the old days. You probably saw my TensorFlow video where I showed you how machine learning works. That we have some neurons right here. That is the input neurons right here. And then we have some output neurons, like if you want to classify an image, if it's an apple, an orange, or banana, then you would have 3 output neurons right here, and then you would have a lot of hidden layers right here where you would have a lot of neurons. Sometimes you would have 128. It's not uncommon neurons in each layer right here, and you would have multiple layers, and you would have to kind of guess and experiment on how to get a good. To get the right result, right? And then the idea is that then you train. You will actually take each pixel value and then you'll put that into each of these neurons right here as inputs. So that means you will have a lot of input values right there. So if it's black and white, it will just be the grayscale value. That means how wide is it? How wide is the pixel? And then from that, you will get some kind of model. If you train it with maybe like 1,000 images, then you can test it with maybe 100 images, and then you get something like a confidence and get some a confidence percentage on how good your model is. That was in the old days. Then you had to invent all of these things right here. You have to love data, and you have to love Python, and you have to love. Arrays inside arrays inside arrays inside arrays. If you really like that, and if you really like math and you really like data, then of course you would continue do this. You don't have to do that anymore. You don't have to think about any of this right now anymore, because what you have to think about now, if you want to do a classification prediction, you actually just need to split up your pictures. So you can actually focus on your images. So you can take a number of images and then label them something. Maybe a picture of me, then it would be Mike, and then a picture of some others. Then you could label them with those. And you don't need to have a lot of labels. That's up to you how many labels that you would like to have. It could also be that you want to know if there are a person in an escalator or something like that or not. Then you can count the people that use an escalator after each day, if that's what you want to do. But I just chose something simple so you can see what Google actually provides and gives us, because it gives us so much. So I have a situation where I went out and I took a lot of pictures of grass, rocks, and dandelions, and also marguerites. So, and after I took those images, then I went to my Google Cloud. I made my I made a project like this, Mike's machine learning demo. And I was really, really amazed on how easy it was. So I went down here and then I created a dataset. So I went to my dataset right here and I named it Stones and Flowers. So I can see you can see here right here, I have 88 pictures in total. I have labeled all of them. If I had some unlabeled ones, then I could press here and then I could start labeling them. But I took 19 pictures of dandelions. You should have like 1,000 images if you want to. That is the best practice. Around 1,000, and you get a really good model. But I've actually done something right here with 19 images of dandelions. And you can see it's mixed with grass, so it's also a bit difficult. And sometimes it's on tiles, so that can be a bit difficult for the model to actually see the difference between this situation and then the rocks, for instance. Here we have the big rocks that are taking up a lot of space right here. I took 34 big images of rocks. I took 14 images of traffic signs, and I took some images of Margaret also, right? 12 images right here. So now I have these five categories right here, that was actually quite easy. I just uploaded those images, of course, and then I added those labels. So the next step then was to create to train a model, because there are a lot of models that you can just use. You can just take them down from the shelf. It's like you don't have to invent all of this stuff that I just showed right here. You don't have to invent that, because there are actually models that will actually help you when you want to classify an image, because that has been done so many times before, and there are people that are smarter probably than you and me that are making these models, so they are optimized for image classification. But what you need to do with them, you need to train them. Of course, you can also take a trained model. That's the next step. But it's not the next step. It's also just something you can take from the shelf, and then you can actually get and then you can actually get an object detection model that has already been trained. That is also something you can just take from the shelf. In this situation, I had this very specific situation where I wanted to have these 5 labels. So that means that I took the pictures of these for these 5 situations and 5 labels, and then I used an existing model, but with my own data. And the model that I used was the AutoML. So the AutoML is something that is made to make the life easy for us. So that means that I pressed train new model right here. I have the model already done right here because it actually takes a long time. It took 1 hour and 38 minutes and actually cost me $20-something or euro. I think a euro, 20-something euro. So it is not free to use to use computation to create your own model and to train your own model. But it was definitely much cheaper than me going out and buying a new graphic card and then using my own GPU and trying to set that up. It was also much easier. So so it was really easy. And but let me just press the training model. Then you can see what we should do. First of all, you choose your data set. In this situation, it's stones and flowers. You can make your own one. It could be with family members or something like that, and then you can classify your family. There are some GDPR rules, of course, you have to follow. So here we have stones and flowers, and here then you can choose which model training method that you want to use right here. And here I chose AutoML. That is where you actually steal, or you don't steal, you reuse, and of course you have the permission to do that. You use a model. Train high-quality models with minimal effort and machine learning expertise. Just specify how long you want to train. Yes. You can also use your own custom training. This is where, if you have these skills where you want to set up these layers right here, and you have a lot of knowledge with that. If you want to be specific on how to set it up, then you would use custom training, and then you can use your TensorFlow skills, and you can brag to your colleagues on how smart you are. In most cases, I would say then you probably want to use AutoML. Okay, so where to use the model? Cloud deployed to an endpoint. That's exactly what we want to do. We want to have a REST endpoint that we can call afterwards, and then it can predict what kind of image that it is that we actually have. So let's just press continue. Then we have some advanced options right here. This is because the images that you're taking, 80% of those will be used for the training. Then you will have 10% for tests, which would give us a number for how good it actually was. And then there's 10% for validation afterwards. So you actually So you need to get. That's why you need to get so many images. So because only 80% of them are used for training, the rest are used for test and validation to get some good numbers on how well your model has been, how well it has been trained, and how good it is at predicting these images that we have. Of course, now we are just playing with images, but it could also be tabular data, and with tabular data, it could be any. That's just any data. That's just data objects, right? It could also be video. But in my situation, it was a data set with images. I'll show you other situations in another video. I chose high accuracy, and then I did not enable incremental training. I just took. This is if you have a model that already has some data already, then you can say, I want to reuse all of the training that this model has already been done to this, and then I want to add on top of that. Then I want to train with these extra images that I have right here. That is of course useful if you get more and more pictures as time flows. So maybe usually when you're a developer, you say that the worst place to actually test your code is in production. But if you are a machine learning engineer, an AI engineer, then usually production is the best. Is actually the best place to do the development. And that means that means is that of course you have to take production images or production examples, and then you have to feed them back into your pipeline, and you can start all over and retrain with the new images that you get over time. And then, and of course, your model will improve over time, of course. So that is the idea. But that is where where Vertex AI pipelines comes in. And I'm not going to show you that in this video. It will come in another video. But for now, we just want to train once. So this is the budget right here. I set it to the minimum node hours. That was 8. Estimated completion 1 hour, and then I press start. I'm not going to press start again because I'm not going to pay for it once again, and I'm not going to wait 1 hour, 1.5 hour. But this was the result right here. So let me just click on my model right here. First I had an error. Okay, let us actually go back. Okay, now we actually came here. So here now I have this is my model registry right here. So that means that now my model has actually been deployed also. So that means I have an endpoint, and if I press my model right here, then we can see that we are actually quite certain, right? It has an average precision, has a precision of almost 99%. That is really, really good. And then there are some other precisions that are calculated in other ways that are 87%. 87.5%. Recall, and it actually uses the original images that was used for the training. It also tries to classify those again, and again we reach the same value of 87.5%. These values right here, if you're more interested, then read the definition of them. But you just need to know that the higher these numbers are, the better it is. The closer to 100%, they will never be 100%. There will always be flaws and errors, but there will probably be less errors than if a human was actually looking at these pictures. Humans would probably make more mistakes than this, right? So. But this is also where I say that you can actually you can take pictures from production, and then you can add them to a data set again. Then you can rerun your training and say this is an incremental training, and then you can get higher and higher percentages. Then we have something called a confusion matrix. The confusion matrix, this shows how secure it actually is, and it is quite secure. Except for, you can see all the blue boxes, those are the good ones. That means that if it's a sign, yes, then we're quite sure. And also if it's a rock, then it will be classified as a rock. If it's grass, then it will be classified as grass. This is the validation images that were used right there. It takes some of your images and then puts it in a bucket named validation. And then it will use those for the validation. And this is where we see the confusion matrix right here. We have the dandelion, and here we have it has a problem seeing, it has a problem segmenting on grass and dandelion. This could actually be because maybe sometimes in the pictures of the grass that I took, maybe there was actually a dandelion. That's one reason. And most of the dandelions, they were, of course, they had a grassy background. So it is okay that it would be confused right here. Of course, if I wanted to use this for something, then I would work on my dandelion versus grass images. So that means I would take a lot more images of grass. I would take a lot more images of dandelion, retrain my model, and then we would see how it went. Okay, so this is the model, Mike. But can you predict something with this now? Yes, of course. Thank you very much for the question. Because now that we have this, we have an endpoint. So now that we have an endpoint and we have deployed it, then how to use that endpoint? Very, very good question. If you don't know how to do that, then you just press online prediction, and then you press sample request, and you get so much help that it is really, really easy. So first of all, if you want to use REST, that's what we're going to do in this video right here. Then we are going to follow this guide right here. That means that you have to give it some input data. That means it should take the content as base 64 encoded bytes, so that you have to convert your images to that, and that's actually a very, very easy tool to use that. Then you have to give some parameters. The confidence threshold 0.5. This means that you will only get the labels that has a has a confidence of 0.5 or above. That means that if there's 0.01% chance of it is being a sign, but there's 99.99% that is a dandelion, then of course it will only give you the response that is a dandelion. It will leave out the rest of the labels. So, Max predictions 5. That means that we will only get 5. We will maximum get 5 labels out. Or what is that actually? Actually, let us play with that. Python, it's just as easy. I'll just save that for another video. So, but for this video, we will use REST, and I've already prepared some examples for that. Let me go to my workspace right here. So here I have a workspace. I actually these images are not my own. These are some that I found on the internet, free to use. And then I try to use those for prediction. I used Dandelion 2, this one right here, because it looks like the pictures that I already had. So I thought it would probably be easy for my model to predict that this was a dandelion. And the same with the rocks. This is the rock that I want to test first. I'll show you how I generate, how I create the base 64 encoded bytes. But for now, you can see we have 2 JSON files. This is the input for endpoint right here. And let me just set the confidence threshold back to 0.3 or something like that. And here we have the content. So this is the base 64 encoded version of the dandelion, and this is the base 64 encoded version of the rock. Actually, I preferred the first one where it didn't break lines, but that's okay. I need to set up my IntelliJ for that, but let us not do that now. So, okay. Yes, that's quite good. So now we have some shell scripts right here. We have to send the endpoint ID, the project ID right here, and then we have to set the data file right here. It uses your own credentials. As you can see right here, it uses these credentials right here. So if you want to use a service account, of course, then you have to place your service account JSON file in some folder, and you have to set up the Google credentials environment variable to point to your service account JSON file. If you want to, but I'm just running as myself right now because I'm super administrator for my own project, so this is fine. And then we just call this endpoint right here, blah blah blah, project ID, locations, blah blah blah. And then predict something. And then we give this input data file. In this situation, it is the rock.json. Let us run it and see what actually happens. So here we have it, try rock. And what did it do? It said that this is a rock. Predictions, yes, with confidence. 0.92, so there's 93. It's 93% sure that this is a rock. So, and it is a rock. So that was quite good. I'm quite happy with that. If I lowered the confidence threshold to 0.01, for instance, what would then happen? Then we will get. What would then happen? Then we should get some more labels. That was what I would expect. Yes, so now we got rock, grass, and Margaret, and the confidences are 93%, 4%, and 2%. So now we got a bit more information. So if it's not a rock, then it could also be grass, and it's actually fair to put it in that category because if I look at my rock too, you can see there's a lot of grass around the rock. I did this on purpose where I had multiple things in the image. I actually wanted to, that's one part of it I wanted to check out. I'm really impressed with how well it actually turned out. Okay, but then let us try the dandelion. So we have the dandelion right there. Let us see how good it will predict that. As the last thing, then I will create the JSON file along with you so you can see how it should be created. First of all, let us see. Dandelion 0.83, so that is 83%. It's 83% certain that this is a dandelion. Okay, it is okay, but it's not. It could be better, right? It's not that good again. So let us just check what the second category is. It could be grass. That is what I would guess, but let us go to the JSON file. Where do we have it there? So we will set this to 0.01 right here, and then we get some more numbers. and then we run the try dandelion again right here. And it's just a curl command. So we're reaching that endpoint with post. We are posting the content of the JSON file to the endpoint. And let's see what we get now. Okay, so now we get, it's not sorted, but that's okay. So we have number 3, that is 8, that is almost 9%. That is the grass. So we have grass, so the grass is second place, right? But it still sees this as a dandelion. So we were 83% sure that it's dandelion, which is quite impressive still. I am super happy for this, and it also gives some other receipt data that this was a model that you called, and it was this first version, etc., etc. That's always nice to get that. Thank you very much for that data. Okay, so now we want to test something a bit more difficult. Let us check this rock, right? Look, there are rocks and there are grass and a lot of weird stuff, and there's also a house on this image right here. So let us take this image right here. Let me just take copy reference, absolute path, because now we come to how do we generate this base 64 encoded version. So first of all, let me just copy input data rock. Now we'll say rock with house. So now we're creating a copy of the existing one right here. Yes, I have to get that's fine. But now we need a new value right here, right? Because now we need the base 64 encoded byte value of the image right here. So that is what we want to type in right here. The confidence threshold. Yeah, let us just keep. Yeah. To begin with, let us set it to 0.5 so we don't get confused. So we don't confuse ourselves. That's fine. Then we create a copy of the shell script. Also try rock with house. Add right here. Rock with house. Boom. Yes. And now we just need to upload the image. So we'll find rock 3 again right here. We'll copy the reference so we know where the path is located, because then we can look at this page right here, base 64 Google converter. This is awesome. It's really, really good for converting base stuff to base 64. It's awesome, but here we can take and encode it to base 64 to image right there. That is image to base 64. So here I just choose a local file, and that is right here. It was not the JSON file. We need the rock. This rock 3. Yes, rock 3 open. Right there. And then we say encode to image to base 64, and then we say copy. We go back to our JSON file right here, and then we say paste. And then we're happy. Maybe we're happy. Let's see. Then we go here, input data. Then we run the script with the new JSON file. That now takes a new JSON file and post that to our endpoint. And don't try to remember this endpoint and all that. You just copy from Google. Google gives you a really good example. Let's just see right here. There are no predictions and no display names. That is probably because it cannot guess what it is, because there are so many weird things in the image. So, but let us just set it to 0.01. 0.1. 0.1. Let us just see that. Let us see what happens now. I'm already a bit sad. I would have hoped for rocks, but let us see. It could also be grass, actually. So let us see here we have. Okay, we have the major one is this one. 47% that it's grass, and that's also true, right? Because all the pictures of rocks that I took, there's 38% chance that it is a rock. I understand why it's confused, because all the images of the rocks, I usually just took one. Maybe there was one or two pictures with more than one rock in it, but most of my images, they only had one rock in them. And here we have a lot of rocks. And we have mostly grass. There are no dandelions in this field right here. There are no margarets. So that's really good. I'm actually, as usual, quite proud of myself. So if you haven't tried it out yet, then only try it out if you really want to see it, because it costs a bit. Yeah, well, okay. We need how much did it cost, Mike? How much did it cost? It costs a lot. That is the traffic to the endpoint. So the dashboard is also quite cool. I just want to see the. Yes, look what's happening right here. Here, look. Here I can see that my image classifier right here, that I was training right here, it used 8 node hours, and that was $27 right here. Yeah. It actually annoys me a little bit. I can feel it, but no, it does not. It was a lot of fun. That is my other project that I have. So, okay, that was actually okay. It's okay. $27 to try something out in Google. It can get expensive, but I'm also quite impressed with the results. And if it was something that could be used professionally, then of course, then it doesn't sound of much. Then the cost is not that high, right? Because this is the training. At some point, if you want to, you don't have to retrain all the time. Every time you get new pictures in from production, you can actually just leave it at this. If this is good enough, and then you only have that expense once. You don't have it every time. Every time there comes new pictures into a system, you could choose to load the images maybe once per week or something like that. Then of course it would be a weekly cost that would be added on top. What I really like about this is that it's so scalable, as just like everything else in the cloud. If you want to scale this, so you can put in more images. So if you want to use a better model, or if you wanted to train a bit more, then you just pay a bit extra, right? So yes. Thank you very much for watching, and have a great evening. I hope to see you again soon. Machine learning, Vertex is awesome. Bye-bye.